Okay, so this is take 1, and this is my practice of resistors in parallel. It consists of 2 resistors with a value of 4 ohms and 2 resistors with a value of 8 ohms, all in parallel. We're gonna use a voltage source just to see what the intensity is on this wire that will later be compared to the equivalent circuit up here, and that intensity should be equal to the one in this wire once we do it. So the first thing we're going to calculate is the total conductance, for which we need the individual conductances of each of these resistors. All we do is we take the resistance value and elevate it to the power of -1, and then by adding it together, we will get the total conductance of the entire circuit. In this case, this is the equation we get, and the result of this equation is going to be 0.75. So we can add that, 0.75, and this is measured in Siemens. So we click OK. Now that we have this, we can replace this in this equation. (0.75), and if we do that, we will see that the result is 1.33, and this is measured in ohms. Now that we calculated these two values, we can make an equivalent resistor, which is going to be this one. We'll make the value 1.33 ohms, and if we see this wire in the scope, when we place these is an arbitrary voltage source. It's just 5 volts for now. When we add it here and we run the simulation, we get 0 volts and we get 3.75 amps. And with our equivalent circuit, we should get the same. And this wire we can also do in scope, and we see 3.76 amps as well. So we can say that this is in fact correct.